Hello students, in continuation to the chapter polymer, now the next topic which we have to take up today, it is about the rubber. Rubber which are to be considered as elastomers because they have a good property of elasticity, stretchability, and I think it's very clear when I say they have the property of stretchability, they are elastomers, so they have weakest intermolecular forces in them, that is van der Waals forces. So in this regard, today we will discuss about two type of rubbers. One is natural rubber, another we will discuss about synthetic rubber as well. The first, it is a time of natural rubber. Now the name tells natural rubber means rubber which is obtained from nature, that is from rubber tree, and in what form? In the form of latex. It is latex, and this latex is a colloidal solution of rubber. It is a colloidal solution of rubber, and this colloidal solution of rubber, when undergo a process called coagulation, then natural rubber comes out. Now this is about the natural rubber. How do we get in what is the rubber? But here we have to discuss about its chemical composition because we are talking in terms of chemistry. So as far as chemical composition is concerned, what do we call chemically? This natural rubber is polyisoprene. Isoprene. Now if you say according to its IUPAC naming, so it is a polymer of 2-methyl-1,3-butadiene. You check it now. If we don't write this, so it is an example of butadiene. This is butadiene. This is butadiene. When you say it is butadiene, and what do you find? 1, 2, 3, 4. So on first and third you get the double bond, so you can write 1, 3 butadiene. But we have 2-methyl, means we have 2-methyl group as well. So this is the compound, this is the chemical which is present in natural rubber. This is called 2-methyl-1,3-butadiene, and it polymerizes, polymerization. You check it now. How does it polymerize? You check it now. I told you earlier also when I was talking about addition polymers. So this bond opens both ways. It opens here and opens here. This bond also opens here. And what do we find? When this bond breaks, it forms a bond on this end as well as on this end. This bond breaks, it forms a bond on this end and forms a bond on this end also. So what do you find? Between these two carbon you get a double bond. You see now. And this CH2 can form bond on this end, so extension is possible, and this can also form a bond on this end, so extension is possible, and this results in the formation of polyisoprene, which is called natural rubber. But this natural rubber has good elasticity. You got it? This was 2-methyl-1,3-butadiene. I am just repeating. Bond opens on both sides. This bond open on both sides. So remember, this bond open on this side, extension. This bond open on this side, extension, and on this side it makes a double bond. Now as far as this, definitely whatsoever property of any compound you observe, it is basically depending on its structure. So what do you find? This polyisoprene is actually a form of cis polyisoprene. You know cis and trans isomers you discuss in class 11th. Cis isomer means when two similar groups are on same side of double bond. So if you observe, this is isoprene, and on this isoprene what do you find? This is the monomer unit. Now when you say this is a monomer unit, you find that this is double bond between two carbon, and on one side two similar group, that is CH2, are on one side of double bond. In this unit, two similar groups CH2 again on one side of this double bond. See individual molecule. This is an individual molecule. Two similar groups are on one side of double bond. Two similar molecules, two similar groups I must say, on one side of double bond. Again two similar groups are on one side of double bond. So what do you say? This is, what does it mean? A natural rubber is made up of isoprene, and its cis isomer undergo polymerization. This is cis isomer. Cis isomer, I just told, two similar groups are on same side. And from CS to end, देखो just check it, ये CS2 ही तो बॉन्ड बनाएगा आपके पास, तो अपने CS2 एंड से ही बॉन्ड बनाता चला जाएगा. But this is cis, this is another cis, this is another cis, same, you will get another cis molecule, and these cis isoprene molecule combine again and again, and this results in the formation of cis polyisoprene. Poly means many, isoprene large number of isoprene. I think it is clear to you. And remember what this configuration helps. Now two things are there. First of all, in this polymer you do not find any polar group. You do not find any polar bond. The bond formation does not involve any kind of dipole-dipole interaction, and it does not involve any hydrogen bonding. So what is left with? So we are left with only weak van der Waals forces. So in these polymers only, what do you find? Long chains are there, and between these long chains we find only and only weak van der Waals forces. Secondly, this cis configuration does not allow the double bonds to come closer. It brings the property to this cis polyisoprene, the property of stretchability. When they have less intermolecular forces, weaker intermolecular forces, it means that this, it seems from this structure also, they can have coil-like structure. And when they will have coil-like structure, so they will have the property of stretchability. So they have the stretchability, they have coil-like structure. Two reasons: one, because of its cis configuration, and second reason, because there are no polar bonding, so there are no strong intermolecular forces, they are having only van der Waals forces. So this is natural rubber, this is its chemical composition. But when we studied about the natural rubber, we came to know, my dear, this natural rubber has very less elasticity. This natural rubber has a good water absorption capacity. This natural rubber can be dissolved or can be attacked by organic solvents, right? And this natural rubber, no doubt, it can be easily attacked by some oxidizing agents. Reason, it's double bond. Reason, it's unsaturation. So in 1839, Charles Goodyear, what he did? To improve the properties of this natural rubber, to get the better properties of this natural rubber, Charles Goodyear carried out a process called vulcanization of rubber. And vulcanization of rubber means this natural rubber is heated strongly with sulfur. We heated it with sulfur at a temperature of approximately 373 to 415 Kelvin. Since at this temperature, on heating with sulfur, process is slow, so we add zinc oxide as an additive to increase the rate of reaction. So this is vulcanization. Now what this vulcanization do? What I told you, why it can be easily oxidized? Because of double bond, because of unsaturation. So what this sulfur do? When the natural rubber is heated with the sulfur, when this natural rubber is heated with the sulfur, what do we find? This natural rubber, on heating with sulfur, it develops certain crosslinks. It makes certain crosslinks, and it makes certain crosslinks with what? You see now, I write it again. This was the polymer chains which were going on. My dear, remember, this is double bond, and the carbon, listen carefully, the carbon which is next to the carbon having double bond. I repeat, this carbon is having double bond, and carbon next to it is called as allylic carbon. So it means that there is formation of bond by sulfur at this allylic carbon. One H is lost. It develops the crosslinks. I hope you got it. Carbon next to carbon having double bond. जिस कार्बन पर डबल बॉन्ड है उससे नेक्स्ट कार्बन एलिलिक, तो एलिलिक कार्बन पर सल्फर अपना बॉन्ड बना सकता है. Now it develops the crosslinks, or sulfur can attack on double bond also. And when it attacks on double bond, what do you find? My dear, it forms sulfide linkage on carbon having double bond. So means during vulcanization, Natural rubber is heated with sulfur, and sulfur develops cross links either at allylic carbon or it develops cross links at carbon having double bond. This is vulcanization. No doubt it improves the properties. It improves the properties. Now the rubber has good elasticity. It doesn't absorb much water. No doubt it cannot be easily acted upon by the oxidizing agent, and it cannot be acted upon by the organic solvents. So all the properties are improved. It is better, it is tough, harder. And what do we find? Remember, if it is heated with, see, natural rubber is heated only with 5% sulfur. You get the rubber which can be used to make tires, automobile tires. And if natural rubber is heated with 30% sulfur, so I know you are aware, we find battery. So battery has the battery cases also. You have seen the black colored battery case that is also made up of the vulcanized rubber. But to make the battery case rubber, we have to heat the natural rubber with 30% sulfur. So this is about natural rubber and this is about its vulcanization. This is about natural rubber and vulcanization. So now what next? लगे हाथ, हम आपसे सिंथेटिक रबर को भी डिस्कस कर लेते हैं. दिस इज नेचुरल रबर. लगे हाथ, हम सिंथेटिक रबर भी आपसे डिस्कस कर लेते हैं. एंड व्हेन वी आर टॉकिंग अबाउट दी सिंथेटिक रबर, माय डियर, वी हैव 3 different type of synthetic rubbers to discuss with us. We have 3 different types of synthetic rubber. Now when I say synthetic rubber means which are purely synthesized. Now when I say which are purely synthesized, भैया एक रबर का स्ट्रक्चर तो नेचुरल रबर से मिलता जुलता है. नेचुरल रबर, व्हाट यू फाइंड? दिस इज नेचुरल रबर. नेचुरल रबर में भी हमने स्टडी किया है. वी जस्ट टॉक्ड विद यू. You just observe natural rubber. This is CH2, this is C, this is CH3, this is double bond, this is H, and this is CH2. Now in this synthetic rubber, what do we find? In place of CH3, we get chlorine. So what do we say? One of the synthetic rubber which is called as neoprene. What do you call? Neoprene. This neoprene is a polymer of chloroprene. And what is this chloroprene? Chemically you can say this is 2-chloro 1,3 butadiene. Exactly same, only in place of methyl we have chloro. You check its structure. This is, you find this is CS2 double bond C, Cl, this is CH double bond CS2. Now this is 2-chloro 1,3 butadiene. Now it polymerizes. Exactly, it polymerizes. And how does it polymerize? Same process, my dear. Bond open on both sides as I told in the case of natural rubber, and you get this polymerized form. CS2 single bond CH, Cl double bond, sorry, H will not be there, double bond CH, single bond CS2. Bond is open on both the sides. This is neoprene. This is perfectly synthetic rubber with many improved properties than natural rubber. It is not easily attacked by organic solvent, not easily attacked by petrol, not easily oxidized even. These are the properties of this neoprene, and because of this reason only, this neoprene find its uses where? In hoses, hose pipes, which you find at the petrol pump as a delivery pipe through which the petrol is delivered in your automobiles. Hoses. And it is also used to make important conveyor belts. It is also used to make printing rollers. It is also used to make printing rollers. And if you observe, there are certain shoe heels which are made up of rubber. Of this rubber they are made of, neoprene rubber. Now, in addition to this, this is about neoprene. We have another. This is called styrene butadiene rubber. Now, this is butadiene rubber, and this is an example of a kind of copolymer. Because 2 monomer units are to be used there. This is also commonly known as SBr. styrene butadiene rubber. Two molecules will be involved. When I say butadiene, CS2 double bond CH single bond CH double bond CH2. This is butadiene and this is styrene, my dear. How do we write? This is CS2 double bond CH and this is benzene. You can also write C6H5. You can also write it as C6H5. Meaning is same. Again it polymerizes. Now again bond is there. You check it now. This bond will open on both sides. This bond will also open on both sides. And this bond also open on both sides. Now check it yourself. Now it polymerizes. This is CS2. Now it is going to form bond on this end. Now just try to get it. It is going to form bond on this end. It is going to form bond on this end also. CH. What do you find? Double bond CH. Now this bond makes bond on this side. Single bond CS2. What else you get? CS2. What else you get? CH. And to this CH, C6H5 is connected and bond is able to form on other side. This is the way how this bond formation actually takes place. This is you call SBR. Just go through it once again. How the bond, I have just shown with the help of arrows only. Because of this, bond opens on this end, on this end, this end, on this end and this end. You just make the bonds. You will get everything. So this is SBR. This is styrene butadiene rubber. My dear, it is very tough than natural rubber. That's why it has much better qualities than the natural rubber. That's why this SBR is used to make the tires, for making of automobile tires, and it is also used to make the floor tiles. Some floor tiles are made up of this SBR rubber as well. This is SBR. This is neoprene. Then the last we have, and this last you can say this is we call butadiene nitrile rubber. In short, it is also known as, it is also considered as Buna-N rubber. Yes, I want to make one more thing clear. It is also called as Buna-S rubber. So this is also called as Buna-N rubber. This is called as Buna-N rubber. Right? Now how it is formed? Butadiene and nitrile. Now you say butadiene. Butadiene again same, CS2 double bond CH single bond CH double bond CS2. This is to be called, this to be known as butadiene. And I say nitrile. So this is, what do you find? This is acrylonitrile actually. This is CS2 double bond CH single bond CN. This is nitrile. Butadiene nitrile rubber. Same. Bond open on both sides. Bond open on both sides. This side and this side. What you will get? This is CS2 single bond CH double bond CH. You check it now. Bond is here, it becomes double bond, again single bond CS2, again single bond CS2, again single bond CH CN. I have shown the opening of bond. Read it once again, you will get everything. So this is called Buna-N rubber. What do you call? Buna-N. Yeah, N. Buna-N. Doesn't matter. Hardly spelling matters. So this is Buna-N rubber we call. Again, it has properties similar to that of neoprene. It doesn't dissolve in solvent. ये solvent में dissolve नहीं होता. Organic solvent से attack नहीं होता. तो again, this Buna-N rubber is made to make hoses. Again, delivery pipe at the petrol pump, petrol tank linings. Somewhere we want to make oil seals, there also it is being used. So my dear, this is all about the different types of rubber, including natural rubber and synthetic rubber. Please read it once again. Thank you and subscribe the channel.